Systems of equations are kind of cool because there are multiple ways to solve them. So in this video, I'm going to show you how to solve this system of nonlinear equations 3 different ways. And it's great to see the benefits of each method so you can make a decision on your own which method would be best given different problems that you may encounter. So I'm first going to solve this system of equations by graphing. We call this graphically solving the system. And to do that, I have to be able to identify what the two curves look like that I've been given. So this first curve, which is x squared plus y squared equals 9, I can identify as a circle. Remember, circles will be in the form of x squared plus y squared equals the radius squared. So I can see I have the x squared and the y squared equal to my radius squared. So this is going to be a circle with a radius of 3 because 3 squared will give me 9. So to graph that circle, I'm just going to go out 3 in all directions. And let me mention one other thing. I do know that the center of this circle is at 0, 0. There has not been any sort of a horizontal or vertical shift. And I can see that because I have an x squared, and that's pretty much the same as x minus 0 squared. We just don't write the 0 generally. And same thing with the y squared. That's y minus 0 squared. So you can see that because we have zeros there, there's been no horizontal or vertical shift. So we're just going to eyeball this. It's not going to be the best circle, something like that. That'll give us the circle x squared plus y squared equals 9. My second curve here is going to be a parabola because I can see that I have one variable squared, but the other one is not. So we'll work on graphing that parabola. We know that parabolas are easier to graph if we have y isolated. So I'll go ahead and subtract the 2x squared and then divide by that -1. So I can get y by itself and take a look at the parabola. Y equals positive 2x squared minus 3. Now, making a table is going to be a little tedious, so I would much rather you use your knowledge of transformations here. We know that this minus 3 is going to shift this parabola down 3 units, and multiplying by 2 is going to cause a vertical stretch. So there's quite a bit of review here of transformations to help you graph this parabola efficiently. So if we go down 3 from the origin, then we know that our vertex will be down here at 0, -3. And then remember, we do have a parent function of y equals x squared. So if you just kind of think about a regular parabola, y equals x squared, normally we have an origin vertex at the origin, 0, 0. And then, we go over 1 and we go up 1 because 1 squared is 1. And then usually we go over 2 and then we would go up 4. I'm just showing you these vertical distances that we'll be traveling up. So up 1, up 4, again, starting from the vertex. So that vertical stretch, we're going to multiply our y values by 2 because we're stretching. They're stretching this parabola up. The y values are going to all get scaled, multiplied by 2. So 1 times 2 is 2, and 4 times 2 is 8. So we can graph that from our vertex going over 1. Normally we would go up 1, but we're going to go up 1, 2, and same thing, left 1 and then up 1, 2. I'm just showing you my little jumps up. I'll erase those though now. So erasing my little vertical movements. And then same thing from that vertex, we will go over 1, 2 units. Normally we'll go up 4 because 2 squared is 4, but now we're going to be going up 8. So we'll count up 1, 2, 3, 4, 5, 6, 7, 8. That will put me at, what is that, positive 2, positive 5, and then same thing, we'll go left 2, and we'll go up 8. Again, I'm just demonstrating how to graph the parabola using transformations rather than plotting points or making a table. So we have now 5 good points on the parabola. You can see that the parabola looks a little bit skinnier because of that vertical stretch, and that looks great. So graphically, we can see that we have a total of 3 intersections. We have one here, and then the vertex intersects the circle at the bottom. So we can say with certainty that we know 0, -3 is one of our solutions. But these other 2 solutions, you're just going to estimate those based off of your graph. So the one on the left side looks like I went left, not quite 2 units, so maybe I'd call that negative maybe 1.8 units. And then it looks like I'm up somewhere around Mine actually looks like 2, maybe a little bit larger than 2, so I might say like 2.1. And then the intersection on the right looks like it's about 1.8 and maybe up a little bit more than 2. But you can see the drawback here, of course, is that these two intersections are just estimates. And that's the drawback to solving graphically, that if we're doing this by hand, there's a lot of room for human error. This brings us to the second way of solving systems of nonlinear equations, and we can solve these systems using substitution. So substitution is where you're going to isolate one of the variables in one of the equations. And you can see on this one, it's much easier to take your bottom equation, the parabola, and let's solve that equation for y. So 2x squared minus y is equal to 3. And we actually did that previously, so we might as well take our previous work. That's going to be y is equal to 2x squared minus 3. And then we're going to take that equation and substitute it into our top equation, the circle, which was x squared plus y squared is equal to 9. But we're substituting in the 2x squared minus 3 from the second equation. So now we just have to be careful with our algebra skills. Often, sometimes people will make a little mistake right here. Make sure that when you take the 2x minus 3 and you square it, that you remember to copy it and multiply it by itself. And that is going to require then that you distribute what some of you might call foiling. We're going to multiply the 2x squared times 2x squared, which is 4x to the 4th. 2x squared times the negative 3 is negative 6x squared. Inside, negative 6x squared. And last, positive 9. So the drawback to doing substitution on this particular problem is the tediousness right here of having to multiply that out. Now, if we combine like terms, we'll end up with 4x to the 4th power minus 11x squared plus 9 is equal to 9. And then we'll want to subtract the 9. So now we'll have 4x to the 4th minus 11x squared, and the 9 subtract out, and this is equal to 0. Then we'll notice that we have a greatest common factor of an x squared, so we'll factor out an x squared. That leaves us with 4x to the 2nd power minus 11. And then because this is a product, we have that 0 product property where we're going to set each factor equal to 0. And in doing that, you'll see we're going to get multiple solutions here. If we square root both sides, we know there's no such thing as a plus or minus 0, so this is just x equals 0. And then if we add the 11 and divide by 4, we get x squared equals 11 fourths. And when we square root both sides here, we are going to get two solutions because we're going to get both the plus and the minus square root of 11 fourths, which if you simplify, I can't simplify the square root of 11, but the square root of 4 is certainly 2. So right now it looks like we have ordered pairs where x equals 0 as one of our intersections, x equals the square root of 11 over 2 as a second intersection, and x equals the negative square root of 11 over 2 as a possible third intersection. So we have to take these values and we have to substitute them back into one of the original equations to then find the matching y values. It does not matter which equation you go back into, but since we're looking for y values, it really does make sense to go ahead and use the work we've already done. And let's go back to y equals 2x squared minus 3. So if we substitute 0 for x, we see that y equals negative 3, and that matches what we got from our graph previously. If we substitute in the positive square root of 11 over 2, remember we're squaring that, then you can see when you square the top, square root of 11 squared will be positive 11, and when you square the bottom, that'll give us 4. So we'll have 2 times 11 fourths. We know 2 divides into 4 2 times, so that will be 11 halves minus 3. This is really 3 over 1, but I'm going to have to get a common denominator there and multiply by 2. So 3 is going to become 6 over 2, and 11 halves minus 6 halves will be 5 halves. So when we had an x value of square root of 11 over 2, we got 5 over 2 for our y value. And then you'll notice, rather than doing this work a second time, if we do a negative, if we substitute a negative, I'll put that in green right here at this step. When I take that negative square root of 11 and I square it, it's still going to give me a positive 11 fourths. So I'll get the same y value of 5 halves. And that concludes solving the system with substitution, and I get 3 answers. And you'll notice if you did put these answers into your calculator, square root of 11 over 2, this is pretty close to the intersection that we did get when we did it by hand. It's just it's a little bit off. And this brings me to the third method of solving, which is solving algebraically, but this time utilizing the elimination method, also sometimes called the addition method. I like this one the best myself because I can see that my x squares are stacked on top of each other. Now I have a y squared and the bottom one is just a y, but that's okay. They're the same variable, they're still stacked. And then I have my constants over here on the other side. So this is set up nicely for elimination. I cannot eliminate the y's because the first y is being squared and the one underneath is just to the first power. So that's impossible. Can't do elimination with y. But because the x's are both squared, we can certainly do elimination with the x squared. So I need to multiply this top equation by a negative 2 because I have a positive 2x squared in the bottom equation. So multiplying the top equation by negative 2 gives negative 2x squared minus 2y squared is equal to negative 18. The bottom equation I have not touched, so that's 2x squared minus y equals 3. So we'll go ahead and do our elimination and add these two equations together. And you notice that the x squareds will be eliminated. Now when I add the y column, I notice I have a negative 2y squared and a minus y. I cannot combine those. Those are not like terms. So the best I can do is just write them both, which would be a negative 2y squared minus y. And then my constants, negative 18 plus 3, will give me a negative 15. Now, this equation that results is a quadratic equation, and we know that quadratic equations can be solved a few ways, but usually we want to set that equation equal to 0 first, and then see if it factors, and if it doesn't factor, we can do quadratic formula. Now, I know most of you probably would add the 15 over because we're so used to bringing everything to the left side of the equation, and that's fine, but in doing that, we end up with a negative leading coefficient, which is not so friendly for factoring. So if you do choose to add the 15 and bring everything to the left side, then I would want you to factor out a negative before you jump into factoring. So that would be a positive 2y squared, a positive y, and then a minus 15 if we factor out a negative. So now, if you didn't take that route, let me just mention here at this step, you could have chosen to take the negative 2y squared and the negative y and added those to the right side of the equation. So let me just demonstrate that, because sometimes having that fluidity, is that a word? We want to be fluid here with how we choose to solve these quadratic equations, and you might save yourself some time then by adding the 2y squared to the right, so it's positive, adding the y term to the right, and then keeping that negative 15. But notice this equation is the same equation I have here, just inside the parentheses. So we really do end up in the same place. So I'm going to go ahead and attempt to factor this. The negative would still stay outside. If you were feeling like your factoring skills were weak, then you could certainly choose to do the quadratic formula. Don't stress about the negative out in front. Remember, I could basically divide both sides by a negative, and the negative would go away. So that negative is not important when it comes time to actually factor or do quadratic formula. So I know I have 2y times y will give me 2y squared. And then my second position here, these values need to multiply to negative 15. So I'm just looking for the right combination. So I'm doing a little guess and check factoring here. I'm thinking it's probably going to be either 3 times negative 5 or a negative 3 times 5. We'll just try, and I'll demonstrate that guess and check since some of you actively use it. So let's say I thought maybe it was a negative 3 and then a positive 5. My outside here, 2y times 5 would be 10y. My inside would be negative 3y, and that certainly does not add up to a negative y, what I need in the middle. So that is the incorrect combination. That's why we call this guess and check. So we erase, and then I would choose to change the order of my values there. So let's try a positive 5 here and a negative 3 here. Outside will be negative 6y. Inside will be positive 5y. If we add those together, we get negative y. So we're a lot closer, but we don't want negative y, we want positive y. So that tells us that we don't have the correct factoring yet, but we're really close. We just need to change our signs. So I'm going to change this positive 5 to a minus. I'll put that in green so you can see the change. And then this negative 3 I'll change to a positive 3. Quick check here, you can see outside is 6y, inside's negative 5y. That's going to work and add to a positive y. So I have the right combination now for my factoring. Again, some of you would have chosen quadratic formula. That's totally fine. But your factoring skills are pretty darn important as you move on in math. So becoming good at factoring, it's a good thing. It'll help you later. We're getting y equals 5/2, and then y equals negative 3. So now we have our y values. That's great. We need x values. So I'm a fan of setting up your blank ordered pairs. So again, I'm getting a y value of 5/2. I don't have the x value yet that corresponds with it, and a y value of negative 3. So now we need to go back to the original system and find the corresponding x values. Remember, you can solve by substituting these into either of the two originals. It doesn't matter which one you choose. Okay, we are looking for x values. So I'm just going to choose the bottom equation. That is just a random choice, 2x squared minus y equals 3. So I'll go ahead and substitute in the y value that I've been given, or that I found, of negative 5/2. Let me start with that one. So that would be 2x squared. If I add 5/2 to the other side, that'll give me 3 plus 5/2. But I know that is 6/2 plus 5/2. So a little fraction work will give me 11/2. Then if I divide by 2, remember that dividing by 2 is the same as multiplying by the reciprocal. So that's really 11/2 times 1/2. So that's going to be 1/4. 11/4. So we get x squared equals 11/4. Finally, we will square root both sides, and we'll have x is equal to plus or minus the square root of 11 over the square root of 4, which is just 2. So when y was equal to 5/2, we had positive 11/2 as one answer, but we're adding another intersection because we're going to get a negative 11 rad 11/2 also. So that adds another third solution. Then I'm going to repeat the same exact process with 2x squared minus y equals 3, but this time we're going to substitute in negative 3 for y and solve. So 2x squared is equal to 0. So we'll get plus 3 and we subtract it over. Then that means x squared is equal to 0 and square root both sides. That gives us x is equal to 0. So we will get our same 3 solutions, just solved a slightly different way. This one was using elimination.